Thank you for joining me on this Friday morning, afternoon, evening / Saturday morning, depending which time zone you happen to be in. I am Olivier, and today we're going to be talking about solving the never-ending requirements of authorization. So very quickly about me, I am a software developer at heart. I've been coding since I was about 8 years old, did like web development consultancy stuff all through my teenage years and university and such. I actually got my first proper job at Microsoft, where I was like a developer consultant. So a nice mix of customer facing, but still quite technical, which is good fun. But ultimately didn't quite enjoy working for a massive enterprise, and then started moving into the world of startups. And I've spent the last 10 years or so of my career working in a number of different startups across a number of different verticals. Spent quite a bit of time in marketing technology, or the MarTech stuff, doing e-commerce systems, personalization systems, recommendation systems, that sort of thing. Also worked in supply chain, connected fitness, finance, a few other bits and pieces. But I started as a developer, and I've always been a coder. I still write code to this day. But I went through various different roles, started as a developer, went on to be like a sales engineer, which is quite an interesting career path if you're looking at how to be technical, but also speak to people. That's quite a good one. Tech lead for a bit, and then about 5 years ago, probably a bit more now actually, went to the dark side of product management, where you suddenly become the one making up all these requirements, which you then have to go and hand off to a developer who may not like it exactly. But my focus when I am working on product side has always been on data and infrastructure components, and data pipelines, data processing systems, recommendation systems, ML systems, security systems as well. Hence, authorization is something that I'm now interested in, and I can now work on the open source project called Cerbos, which I'll come back to at the end of this. So today, just to make sure we're all on the same page, we're going to be talking about authorization with a Z or a Z, depending which part of the world you're in, not authentication. So unfortunately, they're two very different things, but they've been reduced down to this auth N and auth Z terminology. Just to be clear, authentication is when you are confirming someone's identity. So this is logging in with your GitHub account or your Google account, or just putting in the username and password. A user providing some sort of credential to a system, and that system validates that and says, okay, this person is who they say they are. Authorization is the bit that comes next. Once you know who someone is, what can they actually do inside of a system or inside of an application? So I'm authenticated that I'm Alex, but can Alex do everything? Can Alex just edit some things? Can Alex view everything? Can Alex only view some things? That's all the business logic around authorizing what a user is allowed to do with inside of a system. These things get mixed up and conflated all the time. You may be thinking like, oh, in my authentication system, I can give someone a role like they're an admin or they're a user, and that is authorization. That definitely is a type of authorization, but actually the business logic, as we'll go through today, is actually more complex and fine-grained than that, and is a very different kind of problem space around authorization than it is just about confirming someone's identity. So we're going to be talking about authorization, not authentication. So I'm sure many of you are familiar with this quote: "In this world, nothing is certain but death and taxes." Having spent way too long of my life thinking about this problem, I would like to add on here that also the ever-changing authorization requirements. Nothing certain about them. I've had to go and design, build, and architect and re-architect these systems 8 or 9 times in a relatively short career thus far. Every single time it's taken, a good lot of headspace from a product person and then a number of engineers to actually go and code up the logic into an application, just for it to go and be ripped out and had to be rewritten in 6 months' time, just because of something happened inside of the business or inside of the application logic that requires you to go and update all the decisioning and authorization aspects. It sucks. There's better ways to do it. So today we're going to go through hopefully what many of you are working in or will be working out towards, which is scaling a company, starting with nothing, scaling up to meet the highest demands. I've worked at both ends of this spectrum, and in between, and there's numerous touch points and things where you need to start actually putting more thought into authorization than you may have previously considered when you're just quickly building an MVP. So we're going to start off in that blissful days of roles. So this is the world right at the start where you just have someone authenticate, and you maybe have a set of UI or set of features that admins can do, and then everyone else can do everything, do other sort of components inside of the system. So you might have inside of your business logic, inside of your code, maybe you have some API endpoint in like an Express server, and that has a very simple check in it. Then maybe it's like an admin endpoint to ban a user, let's say, if it's like a chat system. You would have some sort of check where if the user's email address contains the email domain of the company that runs the system, you go, okay, they're an employee, they're an admin, they can do everything. Yay, go and let them do it. If they're not, if their email doesn't contain the company's domain, then they're just a regular user, deny them. Very simple to write, one line if statement, no problem, copy and paste it even, no big deal at all. If you're maybe doing something a bit more fancy, you might have like an authentication token and use something like scopes, if you're familiar with that, in your auth token or a JWT token, where you can store a flag that says whether this person is an employee or not. So you're not like hard coding it into your app, but at the core of it, you're having a very simple if statement. The requirements aren't too complex. So that's now going to scale a bit further. You've got your MVP off the ground. You've had those basic roles in there. And maybe you've got a first version of your product shipped with a load of different features out there, and you know, things are going well. You start to go maybe start hiring some people to actually go and sell your system. Now, this is one of the first moments where I found you're going to have to go and rethink how you do permissioning side of a system. Because now your sales team may actually want to go and package or price or combine features in different ways so they can sell them to different users and different hierarchies. You might end up with a entry-level package, sort of a good package, a middle package, sort of a better package, and then a best package, which is like your top enterprise one. And that slices and dices the feature sets or different functionality for those different users across the different packages. So like, okay, well, how would we go and implement that? Well, we can then just go and amend that if statement we had before, where we're saying maybe there's some premium feature. We're going to have a check in here that says, all right, if your email address includes the company email address, it's fine, you're an admin or you're a power user, you can have the feature. Or if you're not, then the company packet, the package that the user's company belongs to is the premium feature. Thus, they should be able to do it or not. And so now we add like one more condition to our if statement. You know, it's not massively complex, and we kind of meet those requirements. We can now go and litter our code base with these sort of extended if statement to do a check, and then allow them to go and access it if they have that particular premium package. And you can maybe go and use like a feature flag system for this as well if you've got one of those in place. Launch Darkly is a very popular one these days to go and control this a bit further. But the business logic, yeah, it's a bit more complicated, but it's ultimately just a slightly extended if statement. It's not too bad. So you've done that, your sales team's happy, and you've got your best, better, good, better, best packages, and you're controlling the features and you're selling them to market that way. Things are going really, really well. And now you want to actually take your product that, say, you built inside of Europe as a European business, and you want to go and run it and sell it into the US market. Well, this is another set of challenges because if any of you are familiar with like terms such as GDPR or CCPA, these are all sort of data protection and consumer sort of information protection rules and compliance things you need to have in place if you want to be able to do data processing on behalf of your users. And if you're processing personal data, people's names, email addresses, birthdays, these sort of things, these regulations cause all sorts of headaches because there's all these stipulations that say data about European citizens must remain inside the EU, data about people that live in California must remain inside of California, and you're going to have to now sort of bifurcate or divide and separate your data and your systems to kind of be able to comply with the regulations, which are just the cost of doing business as you scale up. So your sales team said, right, no, we've decided as a business we are going to sell to the US. It's like, okay, well, as a developer, I need to go and implement these checks in here. So now I need to also add into my authorization logic these further checks to work out where to store data or where to access data or what data a user is allowed to access to. So now that if statement gets a bit trickier. You're now doing the check still for email address. You're still checking the package. But now if they have access to it, you now need to decide, okay, well, where are we going to store or fetch the data from? Because it's relevant about an EU or a US citizen, let's say. You now have this another if statement where you're actually checking an attribute of the user. You know, is this user in Europe? Is this user in the US? Is this person in China? Is this person in Russia? Is this person in, one of these various demographic locations that have data locality laws? So now you have this other if statement where you have to go and check the condition of a user to check if it's in Europe or not, and then have this further conditional logic to work out whether that user is authorized to access a certain bit of data or not. they may be an admin, but they might be in the wrong region because they're trying to access something about a European user, but they're in the US or vice versa. Again, manageable, gets a bit more complicated, and something like data access, that's going to be spread all across your application. So you're going to end up having to copy and paste this if-else logic all over the place, and going to get a bit tricky. But you can do it. You can maybe use things like OAuth scopes again. There are libraries for languages, specific ones. So Castle in the Node ecosystem, can in the Ruby ecosystem allows you to define this more as configuration rather than code, but it's still ultimately inside of your code base, but abstracts it a little bit into like a separate library inside of your app. But yeah, it's manageable, a bit more complicated, but manageable. So now a real tricky one. Things are going really well. You sorted it into multiple regions. You got all the data protection stuff sorted, and you now have this really compelling product, and you want to go and sell it to, say, an enterprise organization. So in previous businesses, I've worked on big data platforms, which are global organizations. So I worked with one of the big airlines in the Middle East. I've worked with one of the big like office supply retailers in the US. And if you go up to these companies, they like are really interested in your product, and you can prove you're going to deliver great value to them. If you start then turning around and saying, okay, we're going to onboard your users into our system, should they be admins or should they be viewers? And that business is just going to turn around and say, no. I'm not going to onboard 5,000 or 10,000 or however many thousands of our employees and have everyone have the same level of access. That's not how these companies work internally. This is how they do not expect all the systems they work with to work either. You're going to have to support these kind of like hierarchy and directory type functionality. So this team can access this part of the system, or this team can only access the resources from their part of the world, or this team can only do certain actions if they're approved by a manager within that team. These sort of directory hierarchies and groups and roles come into play. So now you could go and hack it, and you can maybe create some group logic, and you start storing like a list of groups a user belongs to inside of your own user database. And maybe they're just like hard-coded values. These are managers, these are viewers, these are publishers, these are editors, these are read-only type groups, which you might be able to come up with 5 or 6 buckets that are common across maybe a load of your users. But in reality, these businesses, especially the larger enterprise ones, are going to have extremely complex hierarchies of cross-functional teams from departments and regions and reporting structures and such. And there's just no way you can code that into your application in a sensible manner. So this if statement, even in this version, is getting a bit trickier now. But if you were to try and support all that crazy kind of hierarchical information, it's not going to be possible, particularly if you're trying to standardize it across all your different users, if you're like a SaaS platform. Let's say you overcame that hurdle. You've got groups working. You maybe have some integration with some sort of directory system, etc. And now you're at the point where you got your first maybe enterprise deal through. You kind of got through a lot of the security hurdles. Quite often, if you end up selling to these larger companies, you'll get sent like a security questionnaire. I got one sent the other day. It's like 140 questions around how we approach security from inside of our business before they would use our software. And there's a quick way to kind of get around this, or there's a quick way to sort of prove to the market that your application and your systems and your processes are secure, which is by getting some sort of certification. And you reach a certain size of company, you start hiring a chief information security officer. And these are people that will help you get things like ISO 27001 or SOC 2 compliance, which are the 2 big sort of security standards which you might see. And these standards have a lot of hurdles and things you have to be able to do and demonstrate. And one of those is around logging. So how do you prove via your audit trail and logs that a user has the access they should, or a user tried to do something and then was denied, or this user's you have a set of users that are acting a bit strangely, or potentially could be a breach? How do you prove that? I've been in an ISO standard company before, and every year I used to get dragged into a conference room by a lawyer because I was the product manager responsible for the security of the system, and I had to demonstrate via our logs all the access control logic we had in place and the audit log of who did what, when, where, and why in order for us to meet our compliance every year. So if you were to go and implement this, what does it look like? Well, now you have all those checks like we had before. You're checking email, package, groups, regions, etc. But now you're going to have to go and put a log or an audit log line in somewhere, and you could go and use some logging library. I mean, hundreds, thousands of those out there. You can go and drop in, but it's not just in one place. You're going to have to make sure you're logging the information at every single point in an application where you are doing authorization checks. Going to be quite cumbersome. Manageable, but cumbersome. And then finally, we kind of reach the point at some point in your journey, and you may even start here first rather than doing it at the end, but you need to scale up, and now you're going to make a shift to microservices, because maybe your core application is in Node with like an Express server, but you might have like a product recommendation model that's going to be in Python, and you might have some legacy system that's going to be in Java or .NET and these kind of things. You end up with this web of services in different languages. So now you're going to have to take all that business logic, which you've managed to figure out an if statement that works this way, and translate it into every single language inside of your system in order to get that consistent authorization check. So you're going to have to translate it to Python, Ruby, Go, C#, .NET, PHP, whatever. And when those requirements change, which they will, you're going to have to go back into every single one of those services and translate those business requirements into every single language. Prone to error, prone to overhead. Chance of you having a fully formed team around each of these services and each of these languages is probably not that high. So it's going to take longer and longer to roll out these authorization checks. Core of this, crux of this, conclusion of this is it's complicated, it's fragile, and also because it is security, because it is authorization, because it's access control, if you get it wrong, the consequences can be fatal to a business, because you could start leaking data without realizing it, just because an if statement wasn't constructed the right way, maybe. So there is a slightly new approach if we try and model what this might look like. So we're now in the world of this kind of build versus buy. If you look just at the Jamstack ecosystem, you have all the backends, you have CDNs for pushing the apps, you store your code in a Git repo somewhere, you have various APIs that do various different things like billing and e-commerce and CMS, and you have various front-end technologies, React, you have generators like Next, build tools, you name it, there's a tool out there for everything. So there's very little we actually have to build that's beyond the core of our systems nowadays. If we look at the authentication space, that auth-end space, that bit that does the username and password, I'm sure many of you have heard of Auth0, managed service. You can buy it, plug it in. It's free for most people, which does all the handling of login, managing single sign-on, managing profiles, managing all the security around how you store passwords, etc. for you. And you can drop it in, and you as a developer don't have to think about it. You can just focus on building the core value of whatever application you're designing. So what's kind of been missing from this environment is something that does the authorization piece. So if we were to go and imagine what this looks like, what would authorization as a service be? So at the core of it, we know a user, we know some resource they're trying to interact with, and we know what they're trying to do with it. A basic sort of CRUD REST API, we have a user because they're authenticated using Auth0 or Firebase Auth or Okta or something like that. We have a session, we have a token, so we know who they are. And we know based on the API call, are they trying to create, read, update, delete a resource, or maybe something a bit more business specific? Are they trying to approve an invoice? Are they trying to comment on a photo? These kind of business attributes. So we know the user, the resource, and the actions. And we want to get to a point where we get back an allow or a deny. So this authorization sort of service system would sit in the middle, which would take those inputs of user, resource, action, as well as some sort of policy or configuration that states, under these conditions, this action is allowed or disallowed. And the authorization service would just return an allow or deny, which simplifies the implementation side of things and moves that business logic down and out of your code base and into these kind of configuration policy files, rather than having to hard code it across the application. So what does that kind of look like? Here's just kind of example from an open source project. Cerbos that I mentioned at the start. Here we're actually defining a policy of this authorization logic. So this, we're looking at like a CRM system. So this is a contact resource. And we have some logic in here, which is hopefully, just for all of you who I assume never seen this before, is pretty readable. We have a resource called type contact. It has some actions. We have like a wildcard that says for all actions, if you have the role of admin, you're allowed. For reading, we're saying to allow, you must be a user, but we've also got some conditions. So matching the department must be in sales, or you're in marketing, and another attribute has to be true. But the core thing here, we've taken that business logic, which we had in those if-else statements before, And we're now defining it as this kind of configuration policy file extracted from the code base. It's not in Node, it's not in Java, it's not in Python, it's not in Go, it's not in Scala, it's not in any language. It's pure configuration files. Look, it's YAML, love it or hate it. But the key thing here is we've extracted that business logic out into policy and configuration rather than hard-coded. And there's kind of another trend going on, as well as this sort of build versus buy, decoupling, sort of pick APIs off the shelf type world, which is, if any of you are looking at deployments, you've probably heard of Kubernetes, the way of orchestrating your containers. There's a really nice model here called Sidecars. So when you deploy your application as a container, you can also optionally attach sidecar containers to it. And these are very common in sort of the Kubernetes world to do things like authentication, an auth proxy. There's sidecars that will pick up logging. There'll be sidecars that do metric collection, these kind of things. And what this gives is a nice pattern where allows you to run these auxiliary services alongside your application that do specialized functions. And this authorization service we've been sort of describing here is a specialized function, doing access control logic around who's allowed to do what. And this has some really nice characteristics because it's running right alongside your application. Any concerns you may have had around your application calling out to some other service to do an authorization check and getting a response around latency or performance or security are kind of squashed because this service is running right alongside your application inside the same pod, if you're familiar with Kubernetes terminology. So the request is very, very short, even on the same machine in most cases, depending how you deploy. So latency from that perspective is ultimately negligible. I mean, there is a network hop involved, but it's not going to be massive. It's certainly not going to be going out over the internet where you're going to pick up a minimum of 10, 20 milliseconds of latency. Because authorization, unlike authentication, can't be cached. Once someone's authenticated, you can get that cookie or you can get that token, you can get that session and cache it for 30 minutes and check it again in 30 minutes or however long you want. Authorization, because it's in the critical path of every request, you need to check this request has come in, can this user do this action or not? You need to have a response that's instantaneous because it's in the critical path, plus it can't be cached because it has to be computed every time based on the fresh inputs about the resource and the user and the action. So this model of running right alongside it kind of quells a lot of those issues and is a much better architectural pattern because you're also not calling out to some service over the net, which is, as I said earlier, slow, but also kind of insecure because you're now going to be potentially pushing out information about your principals and your resources or your users and your resources out to some external service somewhere, which you don't necessarily control. It's outside of your network, it's outside of your VPC, it's outside of your security perimeter. So this model is really nice fit for something like authorization as well as what it's used for today. So what does it look like in practice? So you would have your end users. They are using your React application, which is making API calls in the backend from the browser to your API backend. The request comes into your application, which could be a single monolith. It could be a web of microservices. It could be a load of Lambda functions. Doesn't really matter. But from that request, based on the authentication session, who the user is. You can go and look up further attributes about them from like a directory system or your own database about what team or organization or roles they have. You also know the resource that they're trying to access, and that sits obviously in your own application database, say a contact or an expense or an invoice, these kind of things. And then before, as you were seeing, we would have had those big if-else statements comparing the user and the data source and the resource to decide whether someone could do something or not. And then having to replicate that across your code base. In this new model, we would package up that information about the user or principal in this case. It could also be like a machine-to-machine token, the resource and what action they're doing, and send a request over to that authorization service that's running very nearby your application. And your authorization service makes a decision based on those policy files. And those policy files could be living in a Git repo with a nice CI/CD workflow. They could be sitting on disk. They could be sitting in a database. Could be kind of anywhere. And your authorization service, based on the inputs and the policies, simply returns back either an allow or deny back to your application. And now everywhere across your code base, before you had that big if-else block, it's now a single if statement. If allowed, do the thing. If not, return some sort of error. And this pattern opens up two really nice things. Firstly, because the business logic is pulled out of the code base and is now in these policy files and externalized from your code, it means the business logic around authorization, who can do what, can evolve independently of your code base. And if developers, you may be the ones just like building an application based on specification. Ultimately, you're not the one, or developers aren't the ones that hold the business requirements for authorization. You're just going to be getting a ticket or a spreadsheet from, say, a product person or a security person or a customer team member saying, okay, these are the permissions I need. So the requirements sit with these like product teams, etc. So by extracting the business logic out of the code base and putting it into something that's standardized and centralized, there's one place where you can update the business logic. Hopefully, maybe even by someone that isn't writing code. Maybe you can hand it off to a technical product manager or something like that. And the business logic can evolve over time, and you never have to go back to the code and update the logic, because your code base every single time is just making a simple check. Can this user do this action on this resource? The authorization service just says yes or no. So when the policies change, you don't need to go and update or redeploy or retest your code base. That's just a set up once and forget type process, and the policies change. The other big benefit here is now that you have a centralized service that's making your authorization checks, regardless of where the authorization checks are being done from, front end, back end, your Express service, your Node, your Java service, your Python service, your Go service, some async worker queue, some sort of batch job that needs to do authorization checks. Because they're all going through this central service, regardless of where the checks are coming from, as a side effect of that, you're going to get a clean and standardized at this time audit log. At this time, this resource was accessed by this user, tried to do this action, it was either allowed or denied. And that standardized audit log will be the same regardless of where the checks are coming from. So if you happen to be working in any sort of like regulated or compliance industries, so there's a lot of fintech users out there that use systems like this because they have that requirement of having a solid audit log of exactly what happened inside of a system. That's kind of a side benefit of using one of these authorization services. So just kind of wrap it up. Before, you would have had these big if-else style statements where you have to expand and keep evolving this logic and have to go and update your code base every time the requirements change, to a world where you now, inside of your application code, you just have a single call out to do a check saying, I've got this user on this resource trying to do this action, and it returns back either an allow or deny, and simplifies your code base to a single if statement rather than all this complicated stuff before. And then your policies can evolve independently to that. So there's lots of advantages to this. Hopefully you've kind of got the gist of this from now. Logic is defined centrally around authorization. They can evolve independently of the code base. It's agnostic to what framework or language or architecture that your application may be built or deployed in, because it is just a standalone service that you're making API calls to. Because your authorization log is now defined as these policy configuration files, it gives you a great GitOps style workflow. So you can keep the policies in a Git repo. You can run CI tooling around it. You can write unit tests around it if you use something like Cerbos. And when those policies change, everything gets distributed out to all the running instances, and you have standardized authorization across your architecture. And the side benefit of a consistent audit trail. At this time, this principal tried to do this action on this resource, and it's either allowed or denied. But on balance here, it's not all upside. You're now going to have another service that you need to deploy, run, and scale. With Cerbos particularly, we put a lot of effort to make this as easy as possible with no other external dependencies. There is a new domain-specific language that you may have to learn around writing policies in some cases. Using something like YAML is fairly standard. You can have kind of Boolean logic in there using conditions and such. And there is going to be a new component in the critical path, but a good solution to this will always be able to run kind of within your application, alongside your application as well, in a very native feeling format, which shouldn't necessarily be a blocker to the rest of your app. So I'm going to wrap up there. I see a couple of questions. This authorization service that we've been talking about, funnily enough, is exactly what Cerbos is. So Cerbos is an open source project that does exactly this. So everything you've seen today is an open source implementation. It's up on GitHub. It's Apache 2 license, so you can use it inside of your businesses, inside your applications. No cost involved. We released the product. We released the open source version about 18 months ago now. Blockchain.com's trading platform runs on top of Cerbos. We have a big Fortune 500 telecoms companies using Cerbos, as well as a long tail of smaller startups in all sorts of weird and wonderful industries using Cerbos. And the reason why we've released it as an open source project is the alternative here is if you used really to go and hard code that if-else statement. And having gone through all that pain myself, as well as the rest of our team, we don't want anyone else to have to go through that. So Cerbos is that drop-in solution that will do this for you. Cerbos.dev is the website. We have an online playground as well, where you can experiment with these things directly in the browser without having to deploy anything to help you get going. and then github.com/Cerbos if you want to see the source code. It's all in Go if you are interested as such. And finally, if you want some swag, if you've deployed Cerbos and join, we have a Slack community, and let us know. We'll definitely send you out some t-shirts and stickers and pens and such, because everyone likes swag. So that is it for the talk. Thank you for listening. Please drop any questions you may have in the Q&A. Oh, we can see we have one. Where should store authentication tokens after authentication? So this will very much depend on how you are using your or what authentication system you're using. These days, things are very much standardizing around OAuth and JWT tokens. So if you're like a client-side web application, it's sort of common to store these maybe in like a session local storage or a session storage inside the browser. Another option is to store it as an HTTP secure cookie, so it can't be snooped. But the key thing there is that your application needs to know who's authenticated and pass that through to your backend for then checking maybe against your own database or against your own user store and verifying that credential before you use it for authorization. The thing with a token is that's where you can also store, if you use something like JWTs, further attributes like scopes or what teams or orgs or roles. So those high-level user attributes can be actually embedded in your token. But be careful about how big those tokens get, because there are limits and scaling considerations to be had around tokens themselves. Great. Any more for any more? Doesn't look like it. Oh, great. Where big companies like Facebook store the authentication tokens?
Does it? Does it have any REST APIs to access this, like this authorization checks?
Yes.
Or only binaries?
Yeah, so in the case of Cerbos, it exposes a REST API. There's also a gRPC API as well if you want to kind of work at the more low level. But Cerbos, yeah, is basically a REST API. Anything that can make an HTTP call can do an authorization check.
Because if I don't want to use the SDK part of it, can I directly use the REST API, right?
Yeah. There's SDKs for most languages now out there, but the HTTP API is kind of always available regardless.
Okay, does the REST has separate key authentication or something, or it's open?
It's open because the service is designed to run alongside your application, so you're not making a call out.
Okay.
Question here: where do big companies like Facebook store authentication tokens? Generally, these are like OAuth tokens, so they're stored either as like a session cookie or like a local storage. Is it recommended to encrypt the YAML files that contain company auth policies? That is a good question. So the way to kind of think about it is these policy files are kind of like your application codes. And in fact, we recommend storing it in your like Git repo alongside your application source code. So the Cerbos instances will pull them down. The policy files themselves don't actually contain any hard-coded information about users or resources. They're just the business logic around comparing those inputs. All the details about a resource or a principal or a user are sent in at request time when you're actually checking. So the Cerbos instance itself does not store or contain any information about your users or any of the information about your resources. So think of it like configuration rather than actual like code or user details in that sense. So it's not. I don't think there's any need to install them, encrypt them, but your appetite to risk is maybe slightly different to mine.
Can you show us a demo using a playground, if possible,
Sure.
if time permits?
Yeah. So this is the Cerbos playground, play.cerbos.dev. And we have some example projects here demonstrating different applications. The one I'll use here is an expenses system. So this is like a finance application. If you're working inside a company, you have to file business expenses, which either get approved or denied by finance team and your manager and those sort of things. And this playground has a few different components in it. So on this right-hand side, we have some different principals, so my different users. So we have like Sally, she has the role of user, she's in the sales department, she's in this region. This is all the information that would come from your like user database or your authentication system, or be inside of your authentication token. We've got Ian, he's an admin, he's in the IT team. We got Mark, who's a user manager and a sales team. So different users. And here are different resources. These are different expenses. So this one is owned by Sally. It's in, to this vendor, it's $500 in EMEA. We have this one, again, owned by Sally, but it's $1,200. We got this one, which is, this one is actually rejected. And hopefully, if I scroll down a bit, we have all the different actions that have been defined for this resource. And as I change, we're getting that live feedback that tells you for each of these actions, whether it's been allowed or denied for the particular user.
So this is the data that we send through the SDK or the REST API, right?
Exactly. And then if we go and look, sorry.
Yeah. Okay. Yes.
Yeah.
Sorry.
So if we go and look at an actual policy behind it, so this is an expense resource policy. And this resource policy has a number of different rules in it. So here we have like a wildcard rule that says, if you're an admin, then you should be allowed to do everything. To view the action, to view a particular expense resource, you must be the owner of the resource, or you must be in the finance team, or you must be like the manager for the region that the resource has been filed in. We have some more interesting ones here where we're now saying, okay, to do the update action, then you must be the owner of the resource. And an owner is what we call a derived role, which is a condition that says the owner ID attribute must equal the ID attribute of the user making the request. Thus, you are the owner. And we're saying to do this update action, you must be the owner. And also there's this additional condition here, which says the request resource attribute status field must be open. So that maps to this field here. And so here we're actually making logical checks against the inputs. This format, by the way, is called CEL, Common Expression Language, which is a Google open source Go library for defining business logic. It can be very expressive. You can write quite complicated if-else style statements in here. And you can do more like slightly interesting things. So here we're actually looking at not just whether a value exists or equals something, but looking at less than or equal to. And right at the bottom here is an example where we're using timestamps. So we're saying to delete an expense, you must be the owner, and it must have been created within the last hour, but it can't already be approved. So here we're doing some timestamp math to work out how much time has passed since a particular expense was created based on those inputs. So once you kind of start defining your business logic, you start sort of getting the response as you expect. Because we're all good developers, we want to make sure that we are testing things. So one of the nice components of the Cerbos tool or framework or library is you can actually write unit tests. So you can say, okay, for this example, for a given principle and a resource, I expect this to be allowed, this to be denied, this to be denied, this to be allowed, etc. And as you start writing your policies, it will give you the feedback about which tests have failed. So you have a nice test-driven development of what's going on. And if you're storing these in like a Git repo, we publish like GitHub Actions templates, and we publish tooling where you can do like CI/CD style workflows where it will firstly validate that your policy files are in a valid state, and then actually running tests against them before it allows a merge request to go in and then distributes it to the instances. So this is like defining the policies. If you're just getting started and you don't want to necessarily run a load of infrastructure or have to run Cerbos somewhere, we do provide a like demo instance of it. So every playground instance you create on play.cerbos.dev, we actually deploy behind the scenes an instance of Cerbos that loads up the policies that you're defining right here in this browser environment. Now, as it says in red here, this is not designed for production. This is just like prototyping. Requests will be going over the internet. They will be slow. They won't necessarily be the most secure thing in the world because it's leaving your network, but it helps you kind of get started. And we do like even code generation for you where you can just copy and paste and start getting going with Cerbos. So you import our SDK, you connect to the instance that we provide you in this environment, and then in your code base, these are what your decision checks would look like. So here we have a check resource method, which is the main method of Cerbos, so saying go and find out whether these actions are allowed on this resource. We pass in this principal information. So this is from your user database or your authentication token, their ID, their roles, their attributes, the particular resource or resources, because you can batch things up as well. that they're trying to access, what kind of resource, what ID, again, what attributes it has, and then what actions you want to check whether the user has permission for. And you can just do a single action or a list of actions. And also you get back a set of decisions, and you can say, okay, was the approve action allowed? If so, allow them to the approve action. And you can do lots of these in parallel. This is the JavaScript one. We've got Java SDK, Go, Python, Ruby, PHP. There's a .NET one. We have Rust also, which isn't in here, and a couple of others. But yeah, you're asking about the HTTP. There's an HTTP endpoints as well, so you can just use those directly. Yeah, so that's kind of a quick run through of how Cerbos works. A question here around, can it handle policies at individual record level, e.g. only a few columns accessible to certain roles? This actually has an example of exactly this. So the way to approach kind of field level permissions. Firstly, it's advisable not to kind of couple your authorization logic with your database schema, because both of those things are going to evolve independently over time. So rather than starting to define like column level fields as actions, in this case in a policy, the way we kind of recommend to do it is kind of start grouping functionality or grouping fields into tagged or like kind of sets of attributes. So here we have the view action, which for all to view a resource, you must be the owner, you must be in finance, you must be a regional manager. But to view who the approver is, so the approver's ID, the approver's name, the approver's email address, the approver's when they approved it, that kind of thing, you must have either the finance role or the finance manager role, or we have a secondary definition here which says if you're the owner, then you can only view that information if the state of it is approved. So you can sort of do that field level or kind of attribute level type permission thing as well using that model. And it's a bit more flexible this way because you're not deeply coupling it with the column name inside of your database, for example.
Yeah, one lame question. So can we use this for feature toggles?
Yes. So one of the kind of early uses that we found across our users today, that they use Cerbos policies for kind of defining feature access, less so from like a developer type feature flag model, but use it for like product packaging type access. So this person is in this company, they have this package, and then Cerbos will return back all the different feature toggles that should be enabled based on the authorization logic. So yeah, like product packaging feature toggles is definitely a use case where you could use this policy-driven approach, and really any business logic that can be defined as a set of resources and actions, you can model as Cerbos policy as well. In fact, now you've said that, if you go Cerbos.dev/playground, we have a product packaging example here as well. So it demonstrates different product packages, and behind them kind of what feature flags that must be met in order to have access to different set of features. But you can find all this on Cerbos.dev. So just a link to that. If you come to the website, I'm looking at the wrong screen. I recommend joining our Slack community. You can find the link here. We have team members and contributors across the world, so there's always someone online if you have any questions. We also run like free workshops, as you would have seen by this bar here. If you're trying to figure out how to model something, or you have modeled something in your policies and you want someone to have a look over it, we run these for free, and you'll get myself or one of the other team members on a call, and we'll just kind of interactively, typically in the playground, go through your policy or help you write your first policy to get started with. So yeah, as I said, thank you very much for your time. Come and join us on the various social channels and Slack community. Tweet me as well at Alex Olivier, and we're here and happy to help. And hopefully this is one less component you have to build yourselves. We are at it. So yeah, have a good weekend, everyone, and hopefully speak to some of you soon. Thanks.